Okay, so I'm going to demonstrate the mean. So first we need a variable. So we'll take the question, how many cats do you have? So people would answer 0, 1, 2, 3, 4, etc. Interval, ratio, level, measurement. So in this case, y being the generic symbol for a variable, y is going to equal the number of cats that people have. And let's say that you take a sample of people in your neighborhood, you have 9 neighbors, and you ask all 9 people, how many cats do you have? So n would equal 9. So I'm going to pretend like I did this, and I went to person number 1 and I asked them how many cats they have, and then I went to person number 2 and asked them how many cats they have. Person number 3, 4, 5, 6, 7, 8, and 9. Right, so let me write all of this out and put it in a nice little table kind of format for you. Now, each answer that the person gives to the question, how many cats do they have, is going to be an individual score, or a y sub I in notation terms. So their answer, person number 1 says that they have 0 cats. 2 says that they have 0 cats. Person number 3 has 0 cats. Person number 4 has 1. Person number 5 has 2. Person number 6 has 0. Person number 7 has 1. Person number 8 has 1. And person number 9, that weird lady down the street, has 22 cats. All right? So there's our little data table. 9 observations, 9 individual scores. Now this is sample data. We didn't ask everybody in the city, so the symbol that we're going to use is y bar, which is the symbol for the mean for sample data. And the formula says that we need to take each individual score and add them up and then divide by n, or the number of scores, or the sample size. So here's the calculation. So I take each individual score and I sum them all up. 0 plus 0 plus 0 plus 1 plus 2 plus 0 plus 1 plus 1 plus 22 divided by 9 is 27 divided by 9, or 3. So the mean equals 3. And I'm pretty sure you already know how to do that calculation. So in statistics, the number is never the answer. You have to interpret it. Now, the way that you interpret a result is by context. What kind of a calculation or measure were you doing? And what are the units of the variable? In this case, the units of the variable is cats. If we were asking about the number of apps you have on your phone, then the units would be apps. If it was the number of bananas on your countertop, the units would be bananas, and so forth. Now the context, in this case, we're measuring central tendency. We're trying to get at the average number. So typically we say on average people have 3 cats, or it's typical for people to have 3 cats. Now look at the raw data. Is the mean of 3 cats a good descriptive measure? I mean, what we're trying to do here is summarize all of our data with one number. Do you think it's doing a good job of describing these 9 people? Is a cat ownership of 3 cats a good descriptive? What do you think? Well, when we look over the data, actually nobody in the data actually has 3 cats. A lot of people have 0. 3 of them have 1 cat. 1 person has 2. That's the only person that's close. So it's not doing a good job. If we're going to pick one number to summarize everybody, all 9 people, 3 doesn't seem to be a good way to describe typical or average cat ownership. So why is it doing such a poor descriptive job? I mean, it's the mean, you know, it's supposed to summarize everybody. Well, we have the one lady, or man, if you like, who has 22 cats. Now, this is an extreme score. Any score that's extreme low or extreme high relative to everybody else is called an outlier. And when you have an outlier in the data, it tends to bias the mean or push the mean. So if we think about it, most people in our data set, they didn't have any cats, or they had one little cute little kitten, or maybe they had a mama cat, a little baby cat. So they had 2 cats. And then, of course, we had the one huge outlier. And honestly, I did not count the number of cats in this image to see if there's 22, but I'm sure that you get my drift. The mean will always be pulled towards the direction of the outlier. It's always going to be pulled towards extreme values. And I'll discuss that more when I talk about the properties of the mean. But basically, if it's an extreme high value, the mean is going to go high. If it's extreme low value, the mean is going to go low. Now, just for a demonstration, and let me make this clear, we never ever simply erase data that we don't like or because it's inconvenient. So just for demonstration, let's pretend like we did not have the outlier of 22 cats. What would the mean be? Well, again, we do the same formula, except for note that we only have 8 cases now, or 8 scores. So we're going to add 0 plus 0 plus 0 plus 1 plus 2 plus 0 plus 1 plus 1. Let my writing catch up here. And if we add that all up, then it's 5. 5 divided by 8, if I do my math correctly, is about 6, 6.25. I don't know, it appeared and then it just kind of disappeared, but it's 6.25. And then again, we want to put the units on that, so it's 0.625 cats, not dogs or apples. And since it would be really disgusting to have like basically 2/3 of a cat when it's impossible to have like a fraction number, we just usually round it. So you can say on average people have 1 cat, or if you want to just go in between 2 numbers and say a person typically has 0 to 1 cats. And you can see without the outlier, the mean is doing a great job of describing. It captures almost every single person in the sample. Saying that people have 0 to 1 cats is a good descriptive measure. Now again, we would never, ever, ever simply eliminate an outlier because we don't. So what does it mean that the mean is the center of gravity? Well, it's the point of balance for all of the scores. What that means is that all of the scores that are below the mean and above the mean will equal in weight. So think of a seesaw, one that you find on a playground. So we have 2 little kids of the same size playing on each end, and that balancer in the middle, technically it's called the fulcrum. Think of that as being the mean. It's at the center, and it's going to be at the place where there's 2 equal weights on either side. It's going to be exactly in the middle and create a balance. Now, what if we have one child of normal weight and one extra super large child? We'll call this child a very big, heavy outlier. I'm sure you appreciate my drawing. Now, obviously, the seesaw is not going to balance because we have a normal weight on one side and we have a big outlier heavy weight on the other side. So how can we make this seesaw basically balance so that both of these kids can basically play? Well, kids intuitively know how to do this. The larger, heavier kid will move towards the center. So let me just kind of erase this and It always takes a while to erase it. So the larger kid is going to move in towards the center, and the little kid is going to stay as far out as possible. Now the seesaw will be balanced just by, not adjusting the weights themselves, but adjusting their position on the seesaw. Now, the balancer in the middle, the fulcrum, if you look, it's now closer to the heavier outlier, heavier score. In other words, the heavier kid moving in towards the middle is the same effect as the mean moving closer to the outlier. Now in our scenario with the cat data, although I'm not drawing cats, I'm still drawing little kids for some reason, but think about, you have all the regular kind of normal size scores on one side of the seesaw. I don't think I'm going to draw all 8 of them, and then we have the one really big outlier, the lady with 22 cats, on the other side. Now the scores in data can't change, so the only way to bring this into balance is if you actually move the fulcrum, that little triangular balance thing, in towards the outlier. In other words, it's the same effect as having the larger kid moving in towards the center. The fulcrum is actually going to move towards the outlier, and it's going to balance basically both sides. So just think of it as scores having weights. And the mean is always going to be at the place that balances all the weights. And when one is really heavy, it's going to move towards that heavier weight to balance it. So mean is always moved or affected by outliers. Mean is pretty easy to calculate. I'm going to be sticking with the same cat data so that we can compare it with the calculation that we did with the mean. So there it is, all 9 cases of the variable, how many cats do you have? Now the first thing that you want to do when calculating the median is you want to take all of your individual scores, and you're going to have to put them in order from low to high. Now it's pretty easy when you only have 9 scores. If you've got like thousands, you probably want to use a spreadsheet or a computer program. That'll order them for you automatically, actually even calculate it for you automatically. So there I have all the scores, all 9, going from 0 to 22. So that's the first step, and it's the critical step. The next step is you just basically have to find the middle score. The middle score is a score so that there's an equal number of cases below it and an equal number of cases above it. So with 9, I can just eyeball it. I can count 4 down and 4 above, and the middle score is going to be 1, and that is the median. Pretty easy calculation. Now, 50% or half of the scores are below, and 50% of the scores or half are above. So the median actually cuts the data exactly in half. So how do you interpret it? The median is 1. Sorry, that was kind of a weird one. There we go. The median is 1. Well, we're going to interpret it the exact same way that we interpret the mean. All measures of central tendency have the same interpretation. Remember, you want to use context and units. So the context, when you're using a measure of central tendency, is average or typical. And the units, in this case, again, are cats. So the average number of cats people have is 1. Typically, people have 1 cat. And that should look a lot like the same sentences I wrote about the mean, because they're both measures of central tendency. And here's me misspelling interpretation, so I'll just erase that. And basically, just in case you didn't get my point, all measures of central tendency have the same interpretation. So I use the term typical and or average, whether it's the mean, the median, or soon to come, the mode. Right? Now, another thing, while we have the same data, demonstrate how it's not affected by outliers. So let's pretend instead of the lady with 22 cats, we have a lady with 137 cats, a true hoarder. So I take out the 22 and replace it with 137. Notice it doesn't change the median at all. It's still 1. It is unchanged. In fact, it doesn't matter if somebody has 3 cats, 20 cats, 2,050 gazillion cats, because it's just taking into account the number of scores, not their actual value. So it doesn't really matter what the outlier is. Median is not going to be affected by outliers. So whenever you do have an outlier, then the median is the better choice over the mean. You know, a lot of times people ask me, well, what if you have an even number of data? How do you calculate the median? So here, again, just for simplicity, I've got 8 cases. I don't know, let's say that we're measuring, I don't know, the number of pieces of mail you got today. All right, so again, first step, the critical step is taking all of the scores and ordering them from low to high. So you can see me doing this in real time. And there's 8 scores all together. And again, with just such a small amount of data, I can just eyeball it. And I'm going to take the middle 2 scores. Now in this case, they're both the same. So it's pretty easy. The median is 3. All right. So I would say on average, people got 3 pieces of mail today. Or typically, people get 3 pieces of mail. Now, what if the middle 2 scores are not the same? So I'm going to change one of the 3's into a 5. Well, you know, you could, I guess, find the middle point between those 2 middle scores, but you don't need to. You just report both of them. So in this case, we'd say the median is 3 to 5. On average, people get 3 to 5 pieces of mail. It is typical to get 3 to 5 pieces of mail. Now,